So today I'll be handling binary search using JavaScript. So for this case, I'm going to use Node.js. So I've installed Node.js within my machine. So I'll code this solution using JavaScript and then run it using Node.js. So binary search is basically this an algorithm that helps us to search for an element in a given range of values like an array. So there are many ways of searching for a given element within an array. So you can use for loop, you can use while loop, but for that search instance, you will be looping through all the values within that array or list. So actually, by comparing that given value and the value within a given index while looping through, which actually is more complex because it's a linear complexity. You'll loop through all the values that comes before that equivalent value you're searching for. So for this case, we can even try searching for that given value using a for loop and see how long it takes. So given these values, like this given array that has 2, 10, 26, and 45, 67, 13, and 19, and this array is unsorted, so we can loop through this and find the value we're searching for. So we can create a function that's we can say function, and then we say search, and then it's going to take the value that we're looking for. We can say value x, and then we can give it array that's going to search the value within, and then say okay, correct spelling there. So we either return found or not found. For the default case, we can say is return not found. Okay, so if we want to actually console log the results of this, and we can say console, and then we can pass search, and then we pass our value as 3, and then pass values, the array of values there, that's values. So we're searching for the value 3 within the given array, which is 2, 10, 26, and clearly we see that 3 is not within that values of that array. So if we try and run that by saying node binary, so it will give us not found. But remember, we've not actually implemented the algorithm that will determine whether that value is within that given array. So for this case, we're going to use for loop. So we can say for let I is equals to 0, I is less than that array length, and then we increment that. And then, so we'll equate that by saying if value x is equivalent to I, and then check the value of array. Yeah, if it's equivalent, it means the value that's searching for is within that array. So we'd say return found. That's fine. So we can now test that by running the same thing. Okay, we have an error here. That's actually wrong, and then we can clear that. So not found. So actually 3 is not within that array. So we can try 67. So found. Now for this case, we're using loops. So what happens if we have an array with 1,000,000 with values? So that will take definitely a long time because we're looping through all that values. So we're going to do the same using now binary search, and use binary search to find out whether some values are within the array or a given list of array. So quick one. So what we're going to do first is actually sort that array. So we can use it. So we can say let sorted array is equivalent to value, no, we're going to use an array for this case, dot sort. Okay, and then we're going to create anonymous function ab, and then that, and then a minus b. So by doing that, we actually sorted our array. So even if we can check that, we can say console dot log and then say sorted array. If we confirm the values of that, we will find it's actually sorted. Okay, so our result is 2, 10, 13, 19, 26, and 45, 67. So that arrays has already been sorted. So if we can bring that value here and see, so let's first align that, and we got that. So that's actually a sorted array. So what binary tree does is it's going to take this given array and divide it into 2, and so we can actually do that manually. So it will if we divide this into 2, we will get this here and that, and then we'll have the second one being this. Okay, so that's what we get when you divide this into 2. So it will be that. So if we are searching for 67, it will check, it will come and just look at this first segment and see, is 67 within this? No. And then it will come to the next segment and see 67 is kind of within this segment. So it will take this segment for the next consideration and also divide it into 2, of which we will have our 26 and 45 being the first segment, and then we have 67 being on the second one. So that's what binary tree tries to do by dividing a given array into 2 parts, segments, then consider the value that we're searching, whether it's on the first segment or it's on the second segment. So I'm just going to remove this because this is just an explanation, and now we're going to actually do the actual implementation. So first, what we're going to do is create the lower bound by saying that, and then we're going to take 0 because our array starts at 0, index 0, and then our upper bound is definitely the last index of that array. So we're going to say sorted array the length -1. The next thing we're going to do is use a while loop that will divide this given array into 2 segments repeatedly. So we're going to say while lower is less than or equivalent to upper, please run this loop. So the next thing we're going to do is the first run is look for the middle index so that we can use that middle index to divide this array into 2 segments. So we're going to say let's middle is equivalent to, we want to take the lower, and then we want to add the difference between the upper and the lower, which is divided by 2. So we're going to say and remember, we can get, when we take the difference between the upper and the lower bounds, we can have an odd value, and when we divide that by 2, we'll get a decimal point. So we want to lower round that into the lower. So we can use math.flow, and then we can say upper minus the lower, and then divide that by 2. Okay, now let's actually get the value at the middle index. So what is this value at the middle index? So we say middle value is equivalent to this sorted array, and then get using the middle index. So we've actually gotten the value at the middle of this given array. So is it the value that we want? So let's compare it with the value that we are looking for by saying value x is equivalent, compare with the middle value. If it's equivalent, then we're good, because that's what we're looking for. So we can say return found. If not, we want to divide this array by checking on the middle index and see the value, whether the value x is within the first segment or is within the second segment, and then we decide which segment to pass it to the next round. So we're going to say if value x is less than the middle value. If it's less than the middle value, it means the upper bound will change into the middle index, -1 definitely. So we say the upper one would change into the middle index, -1, so that we don't reconsider the same index that we have already considered within the upper one. So, but if it's actually greater, we need to move to the second segment by saying, now changing our lower into the middle index +1, so that we move to the next segment. I guess that's it. Let's see what happens. So we are searching for 67. So let's see if it works. So it's found, actually it's actually there within the range. So we can search for 7, which is not there, so not found. So let's see what we've actually done. What we've actually done is at line 4 we given an array and we're trying to sort it into an ascending order, so that it's actually the smallest values come at the lower indexes, and we have the maximum value coming at the higher index of that given array. And then we try to get the lower one, which is the 0 index, and then take the upper boundary being the maximum index of that given array. And then we use while loop, so that we loop through this given array and divide it into segments until we kind of done, and to know the value is either in or it's out. So at line 10 we're trying to get the middle index of that array, and we take the lower and then take the difference of that the upper and the lower bound, and then divide it by 2, and then we round it down, and then we add it to the lower, so that we get the center of that array. And then we take the value, we want the value that's at that middle index, and then we compare that middle value of that index within the middle index to the value we are searching for. That's value x. If it's equivalent, it means we've actually found what we were searching for. If it's not, we now determine whether the value x is within the second segment or is within the first segment. If it's within the first segment, we'll take the first segment to the next round and divide it into 2, and the loop continues. And when you compare this binary search to the for loop way of finding a value within a given array, this is way much better. So that's it. Thank you.